Alright, so we're going to cover complex numbers. So we've seen in previous sections that the square root of a negative number does not exist in the real number system because there is no real number that, when squared, will result in a negative number. For example, square root of negative 4 is not a real number because there is no real number whose square is negative 4. The square roots of negative numbers do exist, however, under another system of numbers called complex numbers. Before we define a complex number, we must define the number as I. The number I is called an imaginary number. So y'all probably seen this before. Imaginary number I is defined as I equals a square root of negative 1. So if you come into contact with a square root of negative 1, that is an imaginary number. It is classified as an I. So because that, if you square both sides, if you square that I and you square that square root of negative 1, you would simply get I squared equals negative 1. So with that, those are very important facts to remember. So we'll be using them throughout the lesson today. So definitely make note of those. I equals square root of negative 1 and I squared equals negative 1. Alright, so another definition here. A complex number is a number of the form a plus bi, where a and b are real numbers. A is called the real part and b is called the imaginary part. So it's the imaginary part because it is connected with and multiplied times the imaginary number. The following table here will show some examples of complex numbers and their real and imaginary parts. So there. Kind of lays it out as far as which is the real part and imaginary. You can look over those and determine and understand that the ones connected with the I are the imaginary and the ones in front are your real number. So with that, as you'll see, as far as in the 8i section right here, this one, of course there's nothing added or subtracted in front of it, so therefore your real part is 0, imaginary is still 8. As to where here we have the 4, there's no imaginary number connected with it. And so we're going to talk about that. So with that complex number 8i, you're written in the form of, as I said, 0 plus 8i. But as well as with the 4, it's a complex number since it can be written as 4 plus a 0 times an I. Because 0 times the square root of negative 1, because that's what this is saying. This is saying 4 plus 0 times the square root of negative 1, well, that would simply just equal 4. So you can write it that way as well in the complex number format. And so, since all real numbers, a, can be written in the form of a plus 0i, all real numbers are also complex numbers, just as I made the comment a second ago. So real numbers and complex numbers. The set of real numbers is a subset of the set of complex numbers. So, that's exactly just restating this sentence I said above there. So let's look at this. So we got the square root of negative 4. So we take the square root of negative 4, we can break that down, okay? We can say square root of negative 1 times 4. In which case we have the square root of negative 1 times the square root of 4. Well, therefore we know what square root of negative 1 is now, and we know what square root of 4 is 2. So you should get an I for the square root of negative 1 and a 2 for the square root of 4. And it's best practice to write it as 2i, the I following the real number, okay? But in this case, it's not so much a real number, it's a complex number. It's an imaginary number. So with that, you would get 2i. Now if you have the square root of negative 11, you can break this down too. Say square root of negative 1 times 11. And so therefore square root of negative 1 times square root of 11. And therefore the negative 1, the square root of negative 1 turns into I, square root of 11. And you leave it in that format. Nothing can be simplified for the square root of 11. So you simply have I, your imaginary number, times square root of 11. And the last one here is square root of negative 54. Of course, we're going to break that down just like we have been. And we can do that as first thing, square root of negative 1 times square root of 54. And so we're going to know that the square root of negative 1 is an I for your imaginary number. And let's get that 54 broken down. So we take the square root of 9 times 6 gives you 54. So then we can break those into square root of 9 times square root of 6. And therefore we should be given a 3 out of that 9. Square root of 9 is going to give us that 3 there. So then we should be able to get 3i times square root of 6. And that is our final answer in this case. Alright, so that makes a little bit more sense on going through with those. So it's talking about here as far as how we wrote it. Again, you want to write the I in front for the square root, so therefore it didn't get confused as being underneath the square root as here. You don't want to do that. That's a no-go because that can get confusing. So same thing as in they said in part C here, you want to write it like this with your 3i in front of the square root, because if you write that I behind, again, this is no good, right? So you do this, as I mentioned, for the state of being clear, so that the i's aren't in the radical. So it's good practice to do that. Alright, so multiplying and dividing square roots contains negative numbers. So when multiplying or dividing radicals with negative radicands, write each radical in terms of the I first. Remember also, I saw a typo there. I'll have to fix that right there. So I first. Remember also that since I equals square root of negative 1, it follows that I squared equals negative 1. We must keep this in mind when simplifying expressions. So, whenever you see an I squared, understand that means negative 1. So, again, we got the rule. So, the beginning of this lesson, remember this guy, so I equals square root of negative 1, and I squared equals negative 1. So let's do an example. So we have square root of negative 12 times square root of negative 3. Let's go ahead and break that down. Okay, so let's take the square root of negative 1 times 12 times square root of negative 1 times 3. Have this written out there. So therefore we can break up the radical there. And with that, we can simply go ahead and take our negative 1's here and turn them into i's. And then let's break down the 12. There's a 3 isn't going to go anywhere. Then it's going to stay the square root of 3. We're pretty good on that one. Can't simplify it any further. But now when we break this radical up, which is square root of 4 times our square root of 3, we'll see what happens here. Because when you multiply these together, you should get I squared times the square root of 4. And then if you take square root of 3 times square root of 3, well, we should get something a little different here. So now we have, again, I times 2 square root of 3 times I times square root of 3. So now we're going to get I squared times 2 times square root of 9, right? The 9 staying underneath the square root of 3 times square root of 3 gives us 9. So hopefully you see that kind of simplifies further here in a second as well. Our I squared is going to turn into our negative 1. But before we do that, let's go ahead and break down this square root of 9. We should get a 3 out of that, right? So we should get square root I squared, times 2 times 3. So therefore we should get a negative 1 times 2 times 3, which should give us a negative 6 overall. Okay? And so therefore, as we did, we're simplifying this. Negative 1 for your I squared times 6, and we get our negative 6. Alright, so hopefully that makes a little bit more sense on that. So add and subtract complex numbers, okay? Just as we can add, subtract, and multiply and divide real numbers, we can perform all these operations with complex numbers. So adding and subtracting these complex numbers. The procedure here is to add complex numbers, add the real parts, and add the imaginary parts. To subtract complex numbers, apply a distributive property and combine the real parts and combine the imaginary parts. So the imaginary parts you treat as if it was like an x, okay? The I is simply just like in replacing an x in your calculation wise, so don't let it confuse you in the process. It's nothing crazy, nothing new, but you'll see we treat it just as if it was an x, but instead of an x we have an I. So let's look at this. So add or subtract these guys. So in A, we've got a monomial of 7 plus 5i plus another one of 3 plus 6i. Well, there's nothing we really do inside the parentheses. They're simplified down as far as they can go. So let's see what we can do. We just need to combine like terms, right? Put your real parts together and imaginary parts. So in this example, we went ahead and put our 7 and 3 together for our real, and then we put our imaginary of 5i plus 6i. And so when we combine 7 plus 3 gives us 10, and 5 plus 6 gives us 11i, and that's all we got. On B, we got 4 minus 3i minus 10 plus 2i. Now, the big thing that we're going to work on here is this negative, or that minus sign. And that's like saying there's a negative 1 in front of the monomial there. Alright? So, we do the distributive property. So we're going to take negative 1 times 10. Then we're going to take negative 1 times a 2i. So we leave the first one alone. We got 4 minus 3i. And then that positive 10 turns into negative 10. And that positive 2i turns into negative 2i. So now we can add the real parts and add the imaginary parts together. So as we did in the first example here, we're going to take our real numbers, 4 and 10, put them together, so 4 minus 10. And then we're going to say plus, and then the imaginary parts, we have a negative 3 there, and a negative 2 here. So negative 3i minus 2i. Well, we should get a negative 6 up front, and then minus 5i. There we go. That's our answer for that one. So let's do a couple more examples here real quick. So now we have 5i minus 7i. And all we need to do to put that together is simply, there's no real numbers, just imaginary numbers. So if we have 5i minus 7i, well, we have 5 minus 7, which should give us a negative 2. And we have I. That's all we're looking at, okay? On this one, there's nothing else we can do in this front bracket here, right? Negative 4 plus 3i. Then we just have plus 7 minus 4i. Well, there's nothing we need to do to this back portion either. So now we just need to combine our real numbers. So we should have negative 4 plus 7. And then we'll say plus, and we'll have 3i minus 4i. And we have negative 4 plus 7 should give us a 3. And then we have 3i minus 4i should give us minus 1i. So I'll say one imaginary number, so say 3 minus I. Alright, so doing this process here is very helpful when you put your real numbers in one section and then your imaginaries in the others and combine them that way, therefore you don't get confused on what's going on. You have to be very careful though with making sure to keep your negatives in place there, right? For the negative 4 and the negative 4i here. Alright, so make sure to keep on going with that. Now, with that, that'll leave us to the check your understanding. We've got 3 problems for you to work on. Hopefully it made a little more sense. And I'll see you next time.